So in this unit, just to kind of remind you about where we are, we started off this unit by talking about cells. We first began with microscopes, then we moved into cells, cell organelles. We're finishing now in the next week or so, and we're going to be talking about these four concepts, these processes, these things that happen inside of a cell. We spend this week on diffusion and osmosis, and then after our vacation probably we'll talk about photosynthesis and respiration. Okay? So, to start, we're going to kind of review a little, because I know you guys have talked about some of these things in elementary school. If you were to imagine a couple of glasses of Kool-Aid, you probably all made Kool-Aid or something, some kind of drink from a powder. You know that as you add the powder, what's happening to it? It's dissolving, right? And if we were to make 2 glasses of Kool-Aid like that, which one has a higher concentration of Kool-Aid? Trista? Yeah, B. So when we say a higher concentration, we mean it has more Kool-Aid molecules in the same amount of water. Obviously, A has less Kool-Aid, which has a higher concentration of water. A. So B has a higher concentration of Kool-Aid. Maybe it's 95% water and 5% Kool-Aid mix. A is probably like 99% water and 1% Kool-Aid mix. So A has a higher concentration of water, B has a higher concentration of Kool-Aid. So if we were to like imagine what happened to these Kool-Aid molecules in sample A and B, and draw X's representing these tiny little Kool-Aid molecules, we would have less in A and we would have more in B. A lower concentration of Kool-Aid here, a higher concentration of Kool-Aid here. And then this is our water level. Now, let's say I made this Kool-Aid, and it tasted too strong to me. It's too sweet. What could I do?
Add more water.
Raise your hand, please. Ava? I could add some more water. What we would be doing is called diluting it. We would be as we add more water, what's happening to our concentration of Kool-Aid? Goes down. Okay. So, when we make Kool-Aid, when I put salt in this water, I'm making what's called a solution. And as you guys learned back in elementary school at some point, a solution is made of 2 parts. The solute and what? The solvent. You know, that's what a solution is made out of. The solute is the thing that seems to disappear. The thing that's being broken up into tiny little molecules. The solvent is the thing that holds the solid. So if in our glass of Kool-Aid, raise your hand, what is the solute? What's the solvent? Luke?
The powder
Is-
is solute.
Yes, the powder, the Kool-Aid powder we put in there is the solute. What's the solvent? Water. We're always almost going to use water as our solvent. You could have other things, but we're going to generally be talking about water as the solvent. So let's look at some examples. Here I have 2 samples of sugar water. Now if you add some sugar to water, it will dissolve just like salt would. Okay. So if we're thinking about this sugar water, raise your hand if you could tell me. What is the solute? Mia?
The solute?
Yes, the sugar. What's the solvent, Mia?
The water.
The water. So if I have these 2 samples, which has a higher concentration of sugar? Claudia? Sample B. Which has a higher concentration of water, Angela? Sample A. Here I have some salt water. Those little shapes represent a salt molecule. So when I made that salt water up there, what was the solute when I made that salt water mixture? Trista?
Salt.
The salt. And what was the solvent, Trista?
Water.
The water. So looking at these samples, which has a higher concentration of salt molecules? Sophia?
Sample A.
Sample A. Which has a higher concentration of water, Sophia?
Sample
Sample B. That's good. All right, now these are pretty simple. But let's look at something a little bit different. Now, in this example, I'm using glucose molecules, a type of sugar. Okay, I'm making sugar water, basically, with this glucose in the water. First of all, what's the solute when I dissolve this glucose in the water? Jenna?
The glucose?
The glucose. And what's the solvent, Jenna?
The water.
The water. Which has a higher concentration of glucose in this example? Yeah?
Sample B.
But aren't there 6 molecules? There's 6 here and 6 there. Does anyone disagree with Rihanna? Everyone agrees with her? Well, you would be correct. But why? So now you're correct, Rihanna. Why is there a higher concentration of glucose in B?
Because there's less water in the water.
Yes, because there's less water. Even though we have the same number of molecules, because there's less water here, it has a higher concentration. A would have a higher concentration of water. So if you had a tablespoon of water, I could put, or a tablespoon of salt, I could put it in this big container, or I could take the same tablespoon and put it in a small container, and even though it's the same amount of salt, which will taste saltier? The smaller container has a much higher concentration of salt than putting it in a big container. So we're going to be talking about how molecules move in cells. And so if you think back to the cell organelles, think back to the cell membrane. What is the cell membrane? What does it do? What is its function? Bailey? Yeah, it controls what can move into and out of the cell. It's that thin layer around the cell that lets things in and out. When we talk about membranes, we have a few words that we're going to use. Permeable, impermeable, semi-permeable. So membranes can be permeable to a certain substance. And what that means is that substance can move in and out through that membrane freely. So if we imagine like our door in the classroom is a membrane. It's permeable to students, teachers. You can walk in and out. It's permeable to mice, and air, lots of things. Okay. They can freely pass in and out. But that doorway also is impermeable to elephants. Impermeable to cars. Okay? They cannot freely pass through that doorway. Impermeable means a substance cannot pass through. So the cell membrane around the cell is what we call a semi-permeable membrane. It means some substances can pass through while others cannot. What about the substance determines if it can pass through or not? Why was I talking about elephants and cars not being able to come through? What was it about those things? Jenna?
They were too big.
They're too big. Often, things cannot pass through the cell membrane freely if they're large molecules. Often, smaller molecules can pass through. You don't have this slide, but things like water is a very small molecule. Oxygen, carbon dioxide, those kind of small molecules just sort of slide right through the cell membrane like it's not even there. The cell membrane is permeable to oxygen and carbon dioxide and water. Larger molecules have a more difficult time. So if we relate this back to our Kool-Aid example, we have Kool-Aid of various concentrations. Concentration means how strong the solution is, how much of the solute there is in a given solvent. So if we're thinking about the concentration of Kool-Aid and water, describe this glass of Kool-Aid. Grace? Of, we have to be specific, because there's a high concentration of what? And a low concentration of, yes. So there's a low concentration of Kool-Aid here, high concentration of water. How about on the far right? Who could describe that one on the far right using the same kind of terms? Eva? A lower concentration of water and? Yeah, higher concentration of Kool-Aid. We've been talking about molecules here, the molecules of Kool-Aid, molecules of salt or glucose or sugar. A molecule is basically a tiny little bit of something. So the smallest possible amount of salt you could have is a single molecule of salt. Molecules are what all matter is built out of. So when we dissolve something, we're basically breaking it down into single individual molecules of that substance. And molecules have certain behaviors that they naturally follow. And one of those is this concept of diffusion. This is a really important definition you're going to have to know. So diffusion is when molecules move from an area of high concentration to an area of low concentration. That's the definition of diffusion. As an example, if I take this food coloring and I put a drop of it in this water, at first, the food coloring will stay in a little droplet. That's a high concentration of dye. But what's going to happen to it over time? Is it going to stay just a little droplet of dye? No. Because of diffusion, it's going to start to spread out. The molecules of that dye will be running into each other, bumping each other, and slowly it will diffuse throughout the rest of this water. So again, it starts off with a high concentration of dye molecules all clustered together. But it's starting to spread out. And it'll take a little while But we'll look back at this beaker of water in a few minutes, and we'll see how it's changed. But that process is diffusion. Or if Mr. Arcuri comes in my room, opens that back door, and sprays a little bit of Axe spray on himself. He does that every morning. So I walk into the room, and as soon as I walk in the door, I can smell that stench. Because when Mr. Arcuri puts on his Axe spray in the corner of the room near that door, at first, the molecules of that spray are all in a small area when he's putting it on. But what happens to them? They expand, they spread out. They go from a high concentration into a lower concentration, and they gradually expand. The dye in the water is another example. And the reason this happens is because the molecules are bumping into each other. As they bump into each other, they tend to spread out into the areas of lower concentration. Like these molecules, they start clustered together, but they bump into each other till they spread out. If you imagine the dye molecules, this is kind of what happened. When I first put the drop of water, they're all together, a high concentration. But as time goes on, they start to bump into each other, spread out, until they're equally spread out throughout the whole solution. It's still happening. You can see if we look up there, it's still diffusing through that water. All right, 2 more slides. There's a type of diffusion that's really important. It's called osmosis. And osmosis is when it's water that's diffusing across a membrane. So just like other molecules, water also moves from a high concentration to a low concentration. In diffusion, molecules go from high to low concentration. Let's imagine if I could take every 7th grade student, I could probably pack them into this room. You know, everybody standing really close together, it'd be hot and smelly and sweaty, but it could probably fit every 7th grader in this room. Would that be a high concentration of 7th graders? Definitely. So let's say I did that. I forced everybody in here. If all the doors were closed, we would say this classroom is impermeable to 7th graders. But then I opened up that door and I made it permeable to 7th graders. What do you think would happen? What would the 7th graders do? Chris? Yeah, would everybody move over there? Why wouldn't everybody move over there? You'd be just as crowded. What do you think would probably happen? Probably about half the people would go over there and everyone would have a little bit more space. Then I open the door into Miss Canale next door's room. What would happen? They would again spread out. So 7th graders would be going from a high concentration to a lower concentration. Okay? The same is true of molecules. They go from high concentration to low concentration. So let's look at this example. So let's say I have this U-shaped tube. It's hollow, and it's in 2 pieces. In the middle at the bottom is a piece of plastic that's a semi-permeable membrane. It's got little tiny holes in it. Okay. On this side, I put some sugar solution. And on this side, I put some sugar solution. First off, if you look at the purple dots represent sugar molecules. Where is there a higher concentration of sugar molecules in this diagram? Mia? On the right. There's more sugar molecules in the same amount of water. That's a high concentration of sugar molecules. And how about over here? That's a low concentration of sugar molecules. So which way, according to diffusion, which we were just talking about, which way would the sugar molecules move? They would move from where to where? right to left. There's a high concentration here, these are just like the 7th graders. They would want to move over here. But what if they can't? What if this membrane is not permeable to sugar molecules? Well, then they're stuck there. They can't move over here. Just like when the door is closed. Students can't move over there. Okay, what about the water? Where is there a higher concentration of water? Brandon?
On the left side.
On the left. What's over here? What concentration of water? Lower concentration of water. Which way do the water molecules want to move? From left, where there's a higher concentration, to the right, where there's a lower concentration. If this is permeable to water, they will do that. And what it ends up looking like is this. Water molecules diffused from a higher concentration here to a lower concentration here, and the water level would increase because of osmosis. Molecules always move toward the lower concentration. That's an important thing to remember. So, if it's any salt molecules, sugar molecules, moving from high to low concentration, we call it diffusion. If it's water that is moving from a high to low concentration, that's called osmosis. Now, if we imagine some red blood cells, that's what these red things are. A cell is probably about 97% water. Most of a cell is water. If I take that cell and I put it in a solution that's also 97% water, would anything happen to it? No. If there's equal concentrations, there's no movement really, net movement either way. However, if I put it in beaker A has a very low concentration of water. Maybe it's really, really salty water. If I did that, let me put this up for a minute. If I put that what did I say a cell was? What percent water? 97% water. And I put it in super salty water, which is only 90% water. Where is there a higher concentration of water? In the cell. A lower concentration outside. So what would the water do? It would diffuse out. It's going toward the lower concentrations. And what would happen to my cell? If it's losing all this water, it shrinks, it shrivels up, it gets smaller. Well, what if I did something else? What if I put it in something that had a higher concentration of water? What if I take my cell, which is 97% water, and I put it in something that's 100% water? Where's there a higher concentration of water?
In the real water?
Out here. What's going to happen to the water? It's going to go in, and what's going to happen to the cell? It's going to swell up. It can even burst. And this is really important medically as well. You know, every year I run the Boilermaker, and I see people passed out on the side of the road from dehydration. Do you know what they do for people when they're dehydrated like that? They don't give them water to drink because they're passed out or they can't really drink it. What do they do, Ava? They give them IV fluids. They put a bag full of liquid, and then they put it into a little needle which goes into a vein. But they do not give them just pure water in that. If they did, this would happen. And water would go into their blood cells, causing them to swell up and possibly burst. What do they give them?
Like 50%.
There's a name for it. they give them a saline solution, which is balanced with their red blood cells. So they still get water into their body, but without causing their cells to shrink or expand. All right.